Okay, now
Okay,
let
my
me
apologies.
give an introduction of our second speaker. It will be first in Farsi, then in English. سخنران دوم امروز ما خانم دکتر گاندالکر هستن. دکتر دافنه کیلمن گاندالکر دانشمند پژوهشگر کرسی مهندسی سیستم‌های آب شهری در دانشگاه فنی مونیخ هستند و سرپرستی کارگروه نکسوس آب، غذا و انرژی رو بر عهده دارند. مدرک دکترای خودشون رو در رشته برنامه‌ریزی شهری از دانشگاه توکیو گرفتن و دوره پس دکتراشون هم در دانشگاه MIT گذروندن و از اون زمان هم در حرفه برنامه‌ریزی شهری و به عنوان پژوهشگر در مرکز اکولوژی شهری و سازگاری اقلیمی دانشگاه مونیخ ادامه فعالیت داشتند. مطالعات ایشون در مجلات و کتاب‌های علمی فراوانی منتشر شده و در کنفرانس‌های متعددی دستاوردهای پژوهشی خودشون رو ارائه دادن. موضوع پیوند آب، انرژی و غذا موضوعی هستش که در پژوهش‌هایشون در سالهای اخیر بیشتر مورد توجه قرار گرفته و در زمینه علاقه پژوهشیشون هم در زمینه سیاست‌گذاری، مسائل مرتبط با تغییر اقلیم و برنامه‌ریزی شهری کار کردم. در رویداد در واقع درخت زندگی امروز هم به سخنرانی در مورد بازیابی آب‌های شهری فرصتی کلیدی برای پیوند آب، انرژی و غذا می‌پردازم. بعد از معرفی ایشون به زبان انگلیسی ازشون خواهش میکنم که ارائه خودشون رو داشته باشن. Our second speaker is Dr. Gondhalekar. Dr. Daphne Gondhalekar is a research scientist and chair of Urban Water Systems Engineering at Technical University of Munich and leads the team of Water Energy Food Nexus work group. She obtained her PhD in urban planning from the University of Tokyo in 2007, and since then she has actively continued her career as an urban planner and a researcher at Department of Urban Studies and Planning of MIT and Center for Urban Ecology and Climate Adaptation at TUM. Her studies have been published in scientific journals and books. She has presented her research outcomes in many conferences, while her research interests encompass urban water energy food nexus policy, climate change, and integrated urban planning. Water energy food nexus has formed the focus of her research within the last years. At this Tree of Life webinar session, the title of her presentation is Urban Water Reclamation and Reuse as a Key Water Energy Food Nexus Opportunity. Daphne, please.
Thank you very much, Madi. Thank you very much, Dr. Amin, for the very kind invitation. I'm absolutely delighted to be here. I'm going to go to my document quickly. It's a real honor and a pleasure to present here. And I'm an urban planner by background, as I've just been introduced, but of course there are landscapes in cities. And there are also landscapes around cities, and of course cities are connected to landscapes, so that's what the content of my talk will be. So I think I just selected my file and that it didn't show up. Let's just try this again. Okay, here we go. Thank you. So I'm very sorry that my video is not working. I don't know what the problem is. My apologies. So here's the background to what we work on in my group, which is called the Urban Water Energy Food Nexus Research Group. As we all know, we are facing these complex challenges in these days, combination of climate change impacts and needing to mitigate and adapt to them, as well as trying to achieve the SDGs on the one side, and on the other side we have a set of synergy opportunities which arise from these complex challenges. So there are opportunities to look at, for example, climate change mitigation and adaptation jointly in order to be able to improve our capacity to act on climate change. So that's what we like to focus on. The other thing that we know is that cities often lack the capacities to deal with these complex challenges comprehensively. There could be a lack of financial, also personal capacities, also a lack of knowledge. So therefore, cities really need integrated solutions that can address many issues with connected solutions or with single solutions. So to explain a little bit about this approach that we take, for those who are not familiar, it's the water energy food nexus approach, a relatively new concept, which is a form of integrated urban planning, which has been around for many decades, which basically takes the idea of planning cities across sectors and not in silos. So a lot of local governments still look only at the water sector or the energy sector or at transportation or at social institutions, but they cannot look at these sectors together jointly because it's relatively complicated. So that's what integrated urban planning is in our understanding. And this water energy food nexus approach has taken that idea a step further and said, what are the key sectors that we need to look at, assuming that we can't do everything at the same time. So it looks at water, energy, and food specifically, because there are some very obvious connections between these sectors, and planning them jointly can help us to mitigate climate change impacts and also adapt to them better. So some key connections are that it takes a lot of energy to supply water and also treat wastewater. It takes a lot of water to produce energy. Many cases, to, for example, cool power plants, you need a lot of water, and you need a lot of water and energy to produce food. So these things are very obviously connected, and the way that cities are planned at the moment, infrastructure systems are often designed to use a lot, particularly of water and energy. These large centralized water systems, especially wastewater collection systems, need a lot of water just to flush because they have to collect water and then be able to transport it to the edge of the cities where the water treatment plants are usually located, as in the photograph that Sharon showed us a little earlier. So we know that cities generally are using far more of these natural resources than their hinterlands or even our planet can provide. So we want to find ways of bringing this consumption rates down, and decentralized systems could be one way to do this. By moving away from these huge infrastructure systems that use so much water and energy could help cities develop a better adaptive capacity, because these smaller systems are more flexible to climate change impacts, and this in turn could support implementation of the SDGs. So the thing is that this water energy food nexus approach has been around for about 10 years now, and there is a lot of theoretical work on it, but so far there are very few projects at urban scales that actually test what happens when you try and join these sectors together in urban planning. So another point in our work is to say that especially wastewater is a huge opportunity when looking at the water energy food nexus, because wastewater is a huge resource and at the moment it's not being used very much. So what we can see in this table is some statistics by the Food and Agriculture Organization from 2016. This is the Aquastat database that shows us how much wastewater is collected in individual countries, how much of that is treated, and how much of it is reused for any different purposes. And we can see that some countries score very highly, like Israel, for example, where there's a certain lack of water, so there's a big interest, and maybe also the finances in order to recover water and use it. But some countries like Germany, where the finances may be in place, but there may be less of an interest to recover water because it generally rains enough. So water reuse is less than 1%, and worldwide water reuse is only 12%. So there's a big potential here that is not being used at the moment. And water reclamation, which we prefer to wastewater reuse, we call it water reclamation, can also incorporate a recovery of resources that are inherent to this water. For example, it can be used to generate bioenergy, biogas. It can be used to recover certain nutrients that can be used for organic fertilizer. It can even be used to recover bioplastics, metals, antibiotics, and all kinds of different components. And all of these are now developing values on markets that are emerging and that can contribute to sustainable development pathways. So what we do in our Nexus TUM research group is that we work on different case study cities to try this out. And this is one of them. This is the town of Leh in India. It is situated in the Himalayas at about 3,500 meters altitude. We've been working in Leh since 2012. We picked this case study because it's in a very isolated region. The town didn't have contact with the outside world much until the 1980s, and then suddenly it opened to tourists, and it boomed completely since then. 500 hotels and guest houses have opened, and millions of tourists visit Leh. At the same time, as you can see in the picture, it's in a green valley, but the rest of Ladakh is like a desert. It doesn't rain, basically, and the only source of water is glacial melt groundwater. So it's a very good case study to show what happens when there is rapid and partially uncontrolled urban development together with a scarcity of a resource like water. So the other issue in Leh is that there is a lack of management of wastewater. So all of these hotels and guest houses put soak pits, and these polluted the groundwater aquifer. So there was a direct need to act to protect this drinking water source. So what the town decided to do was to hire an international consulting company and said, we need a solution for this problem. And the consulting company said, well, let's build a centralized sewage system. But basically this would mean that the town needs to supply 135 liters per person per day just to be able to flush these long pipes. And this would require a lot more energy than what they are at the moment supplying, which is typically a Ladakhi person uses about 20 liters per day. And you would have to lay huge amounts of pipes. So this is what the diagram on the left is trying to show. And an alternative, which we've been advocating in Leh since 2012, is to have a decentralized approach, to take smaller pockets of the town, supply less water, have smaller systems, in order to be able to recover that water locally to be used for urban agriculture. It could be treated locally using smaller treatment plants that could run with solar energy, and they could use a different treatment system than the kind of conventional sewage treatment plant in many cities worldwide uses, which is also very energy intensive. So we tried to generate some evidence of what the benefits of such a system could be. And we were able to show that, for example, in this pocket that you can see in the picture, the houses with the blue dots were the ones where we said, let's collect the water from there and see how much we can get. The blue surface would be a constructed wetland that could be used to treat that water, and the pink surfaces are barren lands that could then be used for farmland with that recovered water, and those fields at the moment are barren because of the lack of water. So if we could use those to grow vegetables, that would make about 2 hectares of cabbage that can be produced, and these of course have a market value, can be sold to tourists as organic products. We could recover about 8 cubic meters per day of methane, which can be used for cooking, about 30 or 40 people per day, and we can recover about 12 tons per year of organic fertilizer. So those are some figures that we put to the decision makers. And of course, it looks small right now. I mean, cooking for 30 to 40 people per day is not a huge amount of energy, but it's also not nothing. So it's significant. And of course, this can be scaled up as well.
Daphne, sorry to interrupt you. Is it possible for you to speak a little bit louder?
Sure.
Thank you very much. Sorry to.
I'll just try and speak up. So we also showed that a decentralized treatment using a constructed wetland approach would be beneficial in terms of greenhouse gas emissions. It would have much lower emissions than the conventional sewage treatment plant would have, and also would be lower than another option which is being implemented, which is to collect septage from septic tanks and treat it outside of the town. So after we've been meeting the local government in Leh for a few years, they said, well, if this Nexus is such a great idea, why don't you apply it to Munich as well? So we went to the city of Munich and we tried to do something similar here. And the issue in Munich is that the sewage system is over 100 years old, and now it needs a lot of repairs. So in some parts of town, several kilometers of piping need to be replaced, and the whole city has about 2,500 kilometers of piping, and it's estimated that over the next 2 decades, these repairs will cost around 500 million euros. And the thing is that is very expensive, and the city of Munich doesn't really know where to get all this money from. So we started up the study just hypothesizing whether also a decentralized approach with resource recovery could be relevant for Munich. And what we did was to say, well, reclaimed water could also be used for agricultural irrigation of urban agriculture. Let's say that we introduce rainwater harvesting. We figured out that we could use it to cover about 30% of the water demand currently for fresh water, where we're using drinking water to flush toilets. And we could also have biogas production, which could, in theory, cover about 20% of local household electricity demand. So that also is a significant number to consider in terms of climate change adaptation as well as mitigation. And it may be something to consider for the future. Of course, Munich has a fully functional infrastructure system, and the city is very reluctant to think about changing the system. But in light of climate change, it may at some point become necessary for cities to rethink these infrastructure systems and whether it makes sense to keep them running as they are because they use so much water and energy. So here is just the technical system that we proposed, and we also tried to demonstrate how the costs of implementing this decentralized system compare to the cost of the renovation of the centralized system. And we figured out that it would be much cheaper to implement this compared to the repairs, and this investment even in completely new infrastructure could be recuperated within 2 years. So that's it from me, and very happy to take any questions. Thank you for your attention.
Thank you very much, Daphne, for your great presentation. It brought a lot of nice ideas to our webinar. Actually, I had a chance to watch the documentary that you made for that city about it was in Himalayas, and it was really nice. Sometimes what we want to do as a development brings other issues to the city, and the issues become even more important than the benefits that the whole development brings to developing for developing areas. And that was really nice, and it was a good format for presenting the ideas. I think for me, even it was much better than a very scientific paper or a very well-written journal article. But that was really nice. I mean, I really liked the whole idea beyond that documentary, and I really advise our attendees to see that documentary. I think it is available on your CV page of the university, and people just can go and see that documentary. And I think after an initial idea from your presentation, they can really understand that documentary pretty well. If there are any questions, you're welcome. If there are any questions, maybe take one question, or before we go to the next presentation, and leave the rest of the discussion for the very end of our webinar. Are there any questions, Armin? Or do you have any questions, specific questions?
No, thank you. I'll be waiting for the end of the session.
Okay. Thanks so much, Daphne, for your great presentation. We will back, if it is okay with you and you can stay for another hour, it would be really nice, and we can have a discussion at the end of our webinar.